All right, so we're going to finish up law of science today, and we're going to talk about something called the ambiguous case. Anybody know what the word ambiguous means? If you're ambiguous about something, kind of goes either way. You go one way or another. All right, the ambiguous case occurs when you have this information given, when you're given two sides and one angle. If you're given two angles, how do you find the third angle? If I know two angles, what do? Add them up and subtract from 180, right? The only possibility when you have two angles given is that there's one triangle. When the ambiguous case could occur, there's three different possibilities. This is when you're given two sides and an angle. You could have no triangle existing. You could have only one triangle, or you could have two triangles. So I'm going to go through an example right now. The first example I'm going to do is going to have two triangles. Then we're going to work on three examples together. And you'll see how you have to do this on a quiz just to make sure you don't miss the second triangle. And it's not terribly difficult, I promise. This visually shows you the cases where one triangle could exist, no triangles, or two. You don't have to memorize this or anything. This is just a visual representation of how this could occur. That's it. All right, so everybody understand that? But again, this occurs when you're given two sides and one angle. You never write that the other way, right?
No. Happy birthday.
Happy birthday.
Thank you. Rory. Okay, so here we go. Yeah, I got a birthday shout out on my video. Okay, now, guys, look, they're telling you that this is a two-solution case, right? Obviously, on a test or a quiz, I'm not going to. But anytime you survey your information and you say, oh, okay, I have a side here, and an angle here, the possibility of two triangles is real. This is how I do it. You don't always have to do it this way. This is just for me. I like to say, okay, you know what? I'm going to go ahead and set up the possibility. Maybe there's two triangles, maybe there's not. But I'm going to figure it out. All right, this would be triangle 1, and this would be triangle 2. If there are two triangles, the numbers will support it. If not, it'll prove that there's not. But what is given will be in each triangle. So if they're giving you angle A, if they say angle A is 20.5 degrees, if there is a second triangle, angle A in that triangle will be 20.5 degrees. Whatever is given will be true in each triangle. Does that make sense? Okay, so we don't have a picture, so let's draw one. Remember our arbitrary ABC, doesn't matter where you put it, it's okay. But angle A, 20.5. They told me side A is 12, so that's going to go across from A. And they told me side B was 31, so it's going to go across from B. Now, we're going to treat this just like we would any other law of science problem. Do you have an angle and its corresponding side? Yes, you do. So go ahead and set up that proportion. Sine of 20.5 divided by 12 equals what? What's the only bit of information we can find? B. I can only find the sine of B. I don't know anything about C. So I'm going to say sine of B over 31. So we're going to go ahead and solve this like we did yesterday. 31 times the sine of 20.5 equals 12 times the sine of B. All right, divide both sides by 12. And we have the sine of B equals. So go ahead and let's do that in our calculator. I got, what, 0.9047? Again, in your calculators, you guys can just hit second sign and then second answer. And I got, let's do 1 decimal point. So 64.8 degrees. You guys agree? You guys with me? So I'm going to write down, okay, angle B is 64.8 degrees. Now, to finish solving triangle 1, how would you guys figure out what angle C was? You'd add A and B, right? So 20.5 plus 64.8 give me 85.3. then I would say 180 minus that. So 180 minus 85.3. And I get 94.7. You guys agree? Okay. And then we're going to go ahead in a second and we'll find side C. But the way you check to see if a second triangle is present, all right? We were given A, correct? So we found B. Whatever you find, you use that information and you find the supplement. What does that mean, supplement? Supplement means what? Adds up to B. So let's take 180 minus 64.8. See what you get. 180 minus 64.8. I got 115.2. Whoops, that's something. Yeah. 115.2, yeah? Okay. Now, if a second triangle exists, you'll have degree measures left over on this side. Add up these two. What's 20.5 plus 115.2? 135.7. And then I take 180 minus 135.7. And I got 44.3 degrees. That means two triangles are present. What would happen if I found the supplement right here for angle B? Right? I found the supplement. And then when I added in the second triangle, I added A and B together and it was more than 180. Is there a second triangle? No. So that's how you would, the way that you figure out if a second triangle exists. You take the given, make sure it's in both of them. Then you find the next angle, find the supplement of that, and then see if a third angle exists. So now, guys, you've proven, oh, wait a second. This is one of those cases where, given the information, two different triangles could exist. So I'm missing a side length. I know A and I know B. Which side length am I missing? What am I missing? C. So I'm going to find C in both triangles. So I'm going to use the given that they gave me. They told me sine of 20.5 over 12, right? So I'm going to use the information from triangle 1. I have sine 94.7 over C. So to solve this, we're going to cross multiply 12 times the sine of 94.7 equals C times the sine of 20.5. Divide both sides by sine 20.5. And what does little c equal in the first triangle? 12 times the sine of 94.7. What'd you guys get? I just, one decimal's fine. So I got 34.2. Remember, if there's a unit, you need to put it. Yes?
How did you know to use like angle C from the first triangle?
Because we're looking on the first triangle. Now I'm going to come over here and I'm going to use the exact same proportion because that was given to me, right? The given is going to be in both triangles. So I have sine of 20.5 over 12. Now I'm going to find the measurement of C in the second triangle. God bless you. So I'm going to say sine of what? 44.3 over C. And now we're going to find little c on the other side. Same thing. We're going to cross multiply. So you have 12 times the sine of 44.3 equals C times the sine of 20.5. We're going to do 3 more examples here in a second, and you'll see, you kind of see how this comes to light. What is little c in the second triangle? So 12 sine 44.3 sine 20.5. Where'd you get? 23.9? Yeah, me too. So, meters. When you're asked to solve and you're given 2 sides in a triangle, you have to check to see. Is this a major hard concept to understand? No. Is it a pain in the butt? Yes. That's okay. All right, you guys with me? All right, go ahead and get your cameras out. All right, so if you have a problem on a test or a quiz and it gives you 2 angles, how do you find the third angle? Given two angles of a triangle, how do you find the third? Just add and subtract from 180, right? The only possibility in that case is one triangle. It's when you're given two sides and an angle that you have to check for the second triangle. So I look at the information they gave me, and I see two sides, one angle. So, could be a possibility of two triangles. So go ahead and get your possible two triangles set up. I'm going to say, okay, I have triangle 1 here, and I have triangle 2 here. The given information is going to be the same in both triangles. So I'm just going to focus on just the angle itself. The given angle for this set of information, this triangle, was how much? A was what? 144, yeah? So 144 degrees. If A is 144 in the first triangle, then A is going to be 144 in the second triangle. So now draw your picture to kind of get a reference to everything. So here's A, B, and C. We said A was 144. So the side across from A is 17. The side across from B is 3. Do I have a law of sines proportion that I can set up with the given information? Yes. I know that the sine of A is 144 and side A is 17. That's going to be true for all the problems that we're going to do, or all the things we're going to solve here. What piece of information do I know? Side B. That means I'm going to have to find the sine of B. Those two words are very close. I try to articulate. So if we're going to solve this like we've done a million times, we have 3 times the sine of 144 equals 17 times the sine of B. Divide both sides by 17. And you're going to get the sine of B is what? You got 0.1037. Now, in your calculators, guys, you can just hit second sign, second answer. So if I hit second sign, second answer, I get 5.95 degrees. Yeah? You guys with me? Okay, I'm just going to round it to 6. Just because that's a teeny tiny number. That's okay. Can an angle be 6 degrees? Sure. So angle B is 6 degrees. Now, you can continue and finish solving triangle 1. Because how would I figure out what angle C was here? Add and subtract, right? But I'm going to just check to see if a second triangle exists. I need to look and see if a second triangle exists here. All right, so how would I do that? What do I have to find? The what? The supplement. Good. So how do I find the supplement? I say 180 minus 6. Well, what is 180 minus 6? 174. Okay. Whoops. 174. So how would I figure out in triangle 2 what angle C was? What would I do with 144 and 174? I'm going to add them and then subtract from 180. So I get 318. Guys, what happens when you say 180 minus 318? It's a negative 138. Can you have an angle measure that's negative 138 in a triangle? No. So what did that just tell you? There's no second triangle. There's only a second triangle if when you add the two together, it's less than 180. So now we just go ahead and we solve this like we've done every other problem. I'm going to take 144 and 6, add it together, and I get 150, right? Then I say 180 minus 150. Angle C is how much? 30 degrees. So I found angle B, I found angle C, and then I have to find side what? Side C. So I'm going to use 144 and 17. So sine of 144 over 17 equals the sine of 30, which is what we just figured out, over C. So we cross multiply. 17 times the sine of 30 equals C times the sine of 144. Divide by sine 144. And what does C equal? 17 times the sine of 30 divided by sine 1/4. What'd you guys get? Round it to one decimal place. 14 point. Okay, so 14.5. And what was the unit? There wasn't one. So 14.5. All right. Let's move on to the second example that I have here. All right, second example. First of all, survey the information. I have an angle, I have a side, and another side. So what are the what are some possibilities? Could I have two triangles here? Yeah, I absolutely could. So triangle 1 and triangle 2. I have to account for the possibility that there's two. The first example, there was not one. So whatever's given in triangle 1 would be apparent, true, should say, in triangle 2. So A is 47 degrees. Now, this is a little different because they don't give you B. They don't give you any information about B. They talk about C. Don't get hung up on the letters, right? The first one is given. Whatever the second one is that you find, that's the one that you use for the supplement. So if I take my information and I draw a quick little picture, A, B, and C, angle A is 47, side A is 33, side C is 34, so that goes over there. What is the law of sines proportion that I can put together with the given information? Sine 47, good, over 33 equals what? Perfect. Sine C over 34. So we're finding angle C, which is perfectly fine. So cross multiply 34 times the sine of 47 equals 33 times the sine of C. Divide both sides by 33. And you get sine of C is what? 34 sine 47. .7535. So second sine, second answer. And I got 48.9. You guys with me? Okay, so angle C is 48.9 degrees. Right here in triangle 1, 48.9 degrees. Pay attention on WebAssign how they tell you to round. Now, to find the rest of triangle 1, what would I do with 47 and 48.9? You add them up. I get 95.9, then I subtract from 180, and I get what? Add them up. You get 95.9. You subtract, you get 84.1. And you can just continue, and then you find the other missing side, which we'll do in a second. But we have to see if a second triangle exists. So how do I do that? I'm going to find the supplement right here, the one I just found.
Oh, you do it from the one you just
Yep, from the one you just found. So 180 minus 48.9. So 180 minus 48.9 is 131.1, right? Somebody last period was like, oh, you can just go ahead and tell if there's not one. I said, okay. How do you figure out if there's a second triangle? What do you do with those two numbers? Add them. So I have 47 plus 131.1. And I get 178.1. Is that greater than 180? No. So is there a second triangle? Yeah. Is the angle teeny tiny? Yeah, that's okay though. As long as it's less than 180, then there's degrees left over for a second angle to be formed. So my second angle is 1.9 degrees. That is okay that it is minuscule. But you've just proven that, oh my gosh, look, a second triangle does exist. So now we're going to find the missing side in each triangle. In the given information, they told me A and C, so I'm going to find B in both triangles. I'm going to use my original law of sines proportion that they gave me, sine 47 over 33. So over here on the left-hand side, I'm going to say sine 47 over 33 equals sine of 84.1 over B, because that's what we're finding now. We're finding that missing side. So cross multiply 33 sine of 84.1 equals B times the sine of 47. Divide both sides by sine of 47. And little b equals what? What's 33 sine of 84.1 divided by sine 42? No. 7. Yeah, that's a 7. I can't read my own writing. What'd you get? 44.9. That's what I got. Good. 44.9. And then what's the unit? Miles. So now we're going to do the exact same thing, but we're going to use the information from the second triangle. So again, I'm going to use sine 47 over what? 33. And then this time, I'm going to use the sine of second triangle's b, which is 1.9 over little b. So cross multiply. You have 33 times the sine of 1.9 equals b times the sine of 47. Divide by sine 47. And little b equals, so 33 sine 1.9 divided by sine 47. 1.5. So 1.5 miles. Now, let's look at this for a second. Does that make sense? 1.9 is the teeniest, tiniest angle, right? So does that make sense that your side across from that would be teeny tiny as well compared to the other one? That's perfect. So if they say solve the triangle, I'm not going to list. You have to find this, this, and this. You have to find the stuff that's missing. That's up to you guys to be like, okay, look, I have side A and B. I need to find C. I have angle this. I need to find the rest of them. All right, let's do the last one. All right, survey the information. I have an angle, a side, and a side. So that means what's possible? No triangle, just one triangle, or two triangles, right? All right, so get your problem set up. I could possibly have two triangles. So let's say, all right, possible two triangles. So triangle 1, triangle 2. Let's talk about what's given. What is the given angle in this information? Its angle A is 116. So if there are two triangles, if angle A is 116 in the first one, what do you know about angle A in the second one? It's 116. Good. So now let's find, draw a little picture, see what we're looking for. So I have A, B, and C. A is 116. Side A is 128. All right. Side B is 206. So what is the law of sines proportion that they've given us? What's the law of sines proportion that they gave us? Sine 116. Great. Sine 116 over 128 equals. What's the only piece of information I could possibly find? B, correct? Do you know anything about angle or side C? No. So you'd have to say, okay, well, let's figure out what B is. Once I figure out what B is in triangle 1, I can figure out what B would be in triangle 2, see if there's a possible second triangle, all that good stuff. So I'm going to cross multiply. We'll get 206 times the sine of 116 equals 128 times the sine of B. Divide both sides by 128. And the sine of B is, so 206 times the sine of 116 divided by 128. Y'all get 1.4465. Okay, so second sign, second answer. If you guys don't know that little shortcut or whatever, let me know and I'll show you. All right, second sign, second answer. What's your calculator say? It says error. What does that mean? There's no triangle. Your answer here would be no triangle. So we just did 3 examples. In the first example, how many triangles were there? Just one. Because when we found the supplement, it was more than 180. In the second example, there was 2 triangles. In the third example, there was no triangle. So that's why it's important, guys. When you get error in your calculator, it's almost a relief. You're like, oh, okay, good, I can move on. It's the second triangle. You cannot miss it. It can occur, and it only will occur when there's 2 sides and 1 angle. Does that make sense? Okay, good.